Okay, in this video, I'm just going to go over the entire study guide for exam number 2, which is on the 23rd of October. I went over part of it in class, but I did not get a chance to go over the whole thing. But in this video, I will go over the entire study guide. Okay, in problem number 1, it's just a true-false statement where 36 is a factor of 6. And you just have to answer true or false. In this case, the word factor means that it has to be a number multiplied by another number that's going to give you 6. And that's not the case here, because 36 can't be a factor of 6. So here, this will be false. And factors, we're talking about whole number. 36 multiplied by a whole number must give you 6, and that's not the case. Now, 36 is a multiple of 6, but it's not a factor of 6. Okay. Number 2. Use the divisibility test to answer the following. Now, you will be given a help sheet that has the divisibility rules there. And I think I gave you a handout of that in class before. The first one, can 702 passengers be assigned to 9 flights so that each flight has the same number of passengers? Well, for the 702, if I take the sum of the digits 7, 0, and 2, I would get 9. And the sum of the digits here must be divisible by 9. So in this case, 702 is divisible by 9, so that answer is yes. We can assign 702 passengers to 9 flights so that each flight has the same number of passengers. The second part, can a parking lot designed to accommodate 3,139 cars be divided into 11 equal rows? Well, let's look at this. We have to take the sum of the first and the third numbers. That's 3 plus 3. That equals to 6. And then the sum of the second and the fourth numbers. 1 plus 9, that's going to give you 10. And then we got to do 10 minus 6, which is 4. And in this case, 4 is not divisible by 11. Okay? That's one of the divisibility rules that I gave you about 11. So here, that answer there would be no. Okay. Now here's the divisibility rules that I was talking about here. For 11, the sum of the digits in the places that are even powers of 10 minus the sum of the digits in the places that are odd powers of 10 must be divisible by 11. Now, I think I told you on the sum of the digits, not the difference. So if I add 10 plus 6, that would give you 16. And anyway, 16 is not divisible by 11 to begin with. So that means that answer there would still be no. Okay. Okay. In fact, I was right in the first place because some of the digits that are in the places that are even powers of 10 minus the sum of the digits in the places that are odd powers of 10. So we have to subtract 10 minus 6. That would give you 4, and that would still be no. Okay. Apologize for that. Can a theater charging $6 per person for admission to a play take in exactly $2,312 for a night's performance? In this case here, for it to be divisible by 6, that integer has to be divisible by both 2 and 3. Well, it is divisible by 2 because the last digit in that number is a 2. But what about by 3? In this case here, we have to take the sum of 2, 3, 1, and 2. And that's going to give you 8. And 8 is not divisible by 3. So here, that answer there will be no, because it's not divisible by 6. Okay. Alright, number 3. Use the divisibility test to test 790,929 for divisibility by 4, 9, 5, and 6. Okay. Now I might need to move this up to the side so I can bring this paper up a bit. For it to be divisible by 4, according to this, the last 2 digits of the integer represents a number divisible by 4. Well, the last 2 numbers are 2 and 9. 29 is not divisible by 4. So that answer there is no. This number is not divisible by 4. What about by 9? Well, but for it to be divisible by 9, the sum of its digits must be divisible by 9. So if I add 7 plus 9 plus 0 plus 9 plus 2 plus 9, let's see, this would be 16, 25, 27, 36. Well, 36 is divisible by 9. So that answer there would be yes. How about by 5? Well, for it to be divisible by 5, the last digit has to be divisible by 5. It ends in 0 or 5. This one does not. It ends in a 9, so the answer there would be no. And then by 6. That number has to be divisible by 2 and 3. It's divisible by 3, but it's not divisible by 2 because it doesn't end in 0, 2, 4, 6, or 8. So that answer there will be no. Okay. Okay. All right, on to problem number 4. Use divisibility test to determine whether 5,349,210 is divisible by 15. Well, for it to be divisible by 15, it has to be divisible by 3 and by 5. Looking at this, we know it's divisible by 5 because it ends in 0. For 3, we have to take the sum of those individual digits in that number. Let's see, if I add 5 and 3, that's going to be 8 plus 4 is 12 plus 9 is 21. 21 plus 2 is 23 plus 1 is 24. And 24 is divisible by 3, so this number is divisible by 15. All right. Number 5. Determine whether the number 175 is prime or composite. Prime means that you only have 2 factors, the number itself and 1. Composite means that there are more than 2 factors. In 175, we have more than 2 factors here, because I know 175 is divisible by 5. So in this case, we have this number is a composite number, okay? Because I know 5 can go into 175. Number 6. What is the greatest prime you must consider to test whether 6,916 is prime? Alright, in this case here, to determine the largest prime number to consider if a given number, n, is prime, we're going to use this. P is less than or equal to the square root of n. P is that prime number, and the n is the number that we're dealing with here. So here we're dealing with 6,916. So that P has to be less than or equal to the square root of this number, 6916. And on the calculator, you can do the square root of 6916. And I come up with 83.16249,155, which I'm going to round to, let's say, 83. And is 83 a prime number? Well, based on this sieve of Eratosthenes, 83 is prime. So that would be the largest prime number that we can use to test whether 6,916 is prime. Okay. Number 7. Find the prime factorization of 2,205. Find the prime factorization of 2,205. And I like to create a factor tree that's going to help me do the prime factorization. In this case here, I know 2,205 is divisible by 5, so I use 5. And divide 2,205 by 5, and that would give me 441. Now I can break 441 into a product of two numbers here. Let's see, 441 I know is divisible by 9. So let's use 9, and then 9 goes into 441 49 times. And then I can break 9 up into 3 times 3. Now notice that the 3 is prime. I'll circle those. 49 can be broken up into 7 times 7. And 7 is also prime, so I will circle those. Now, the prime factorization, now these numbers don't necessarily have to be in any particular order. Here, 3 times 3, that'd be 3 squared, times the 5, times 7 times 7, that's 7 to the second. So this represents the prime factorization of 2,205. 3 squared times 7 squared times 5. Alright, problem number 8. In number 8 it says, find the prime factorization of 6 to the 5th times 14 times 169 to the 11th power. That's 6 to the 5th times 14 times 169 raised to the 11th power. Alright, in this case here, I can write 6 as a product of prime factors. In this case, 2 times 3. And then I have to bring over the exponent of 5 because that product is raised to the 5th power. That 14, I can break that up as a product of prime numbers, 2 and 7. So 14 will be 2 times 7 times 169 is 13 times 13. and that product will be raised to the 11th power. Okay? Now, each number in the parentheses is going to be raised to the exponent on the outside. So this 2 will be to the 5th power, and the 3 will be to the 5th power. Then times 2 times 7 times 13 is going to be to the 11th power, and this other 13 will be to the 11th power. Alright, so now, when we multiply powers of the same base, we always add the exponents here. So for 2 to the 5th times 2, and that's 2 to the 1st power. Here we write the 2 down and add the exponents for the 2. So 5 plus 1, that's going to give us 6. Times, let's see, I have nothing with 3 to the 5th, so I bring that down. Times 7, bring that down. For the 13 to the 11 times 13 to the 11th, bring over the 13 and add the exponents to the 13. So it'll be 13 to the 22nd power. So this is the prime factorization of this expression here. 2 to the 6th times 3 to the 5th times 7 times 13 to the 22nd power. Alright, number 9. Finding the greatest common divisor and the least common multiple for two numbers here, 62 and 14. The greatest common divisor was 62 and 14. And also we're going to find the least common multiple as well. Let's start out with 62 and 14 and write those as prime factorizations. That would be the best way to do this. I know 62 is divisible by 2, and I can divide 2 into 62. That's going to go 31 times. The 2 is a prime number, and also 31 is a prime number. So 62 breaks up into 2 times 31. 14 can be broken up into this. 2 times 7. 2 is prime, and 7 is prime. Now, from this we can find the GCD. The GCD is the common factor that's in both of these terms, both of these numbers here. The common factor that's in both is only the 2. So that GCD is 2. Now for the LCM, the least common multiple. Now, we've already got our prime factorizations for 62 and 14. To find the least common multiple, we use each factor the greatest number of times that it occurs in any one factorization. So in this case here, we use the 2 only once, because it occurs in only once in either one of those factorizations. The 7 we also use only once, and 31 we use only once. Now multiply 2 times 7 times 31, and you'll get 434. So in this case here, the least common multiple of 62 and 14 will be 434. The GCD is 2. Alright, number 10. The hardware store sells bolts in packages of 8, nuts in packages of 6, and washers in packages of 4. What is the least number of bolts, nuts, and washers that can be... number 10 is this. Midas has 135 silver coins and 225 gold coins. He wants to place his gold coins and silver coins in stacks, so that there are the same number of coins in each stack. What is the greatest number of coins that he can place in each stack? Okay, so that's number 10 that I was trying to read. Alright, here we need the greatest common divisor of 135 and 225. I can do prime factorization as well here. I know 135 is divisible by 5. And 5 can go into 135 27 times. And then 27 can be broken up as 3 times 9. And I'll circle these prime factors. 9 is 3 times 3. And 3 is prime. Now for the 225. That's divisible by 5. And 225 divided by 5 would be 45. And 45 can be broken up as 5 times 9. And by the way, 5 is prime, so I'll circle those. And 9 is broken up as 3 times 3. And 3 is prime. Alright, now, here we're going to match up our common factors here. Here I do have a 5, 1 5 that's in both of these that I can match up. So here, I have a 5. I can match a 3 with this 3. And guess what? I can match this 3 with another 3. Okay. So here we're using each common factor, well, the common factor that's in both, we use it the least number of times. So here, 5 is only used once. 3 is used twice here, and this 3 in 225 is used, well, the 3 here is used 3 times. This is used twice, so we have to use the 3 twice, the least number of times. So if I add 5, multiply 5 times 3 times 3, it would be 45. So the greatest common divisor would be 45 of those two numbers. So to answer the question, 45 would be the greatest number of coins that Midas can place in each stack. Okay. Now number 11. In number 11, the hardware store sells bolts in packages of 8, nuts in packages of 6, and washers in packages of 4. What is the least number of bolts, nuts, and washers that can be purchased? So there is an equal number of each. I like to list the multiples of 4, 8, and 6. Or 8, 6, and 4, whichever you want to call it. 8, 6, and 4. For 8, I have 8, and then 16, 24, 32, 40. Now for 6, that will be 6, 12, 18, 24, 30. And I can see that 24 is in both of these, the 8 and the 6. Now for 4, this will be 4, 8, 12, 16, 20, and I'm going to carry this out to 24, because I see here that 24 is the smallest multiple for 8, 6, and 4. So that least common multiple is 24. That's the least number of bolts, nuts, and washers that can be purchased. So there is an equal number of each. Number 12 is finding the opposite or the additive inverse of 97. Well, it's a positive 97, so the opposite of a positive 97 is negative 97. Okay. Number 13. Evaluate the absolute value of 46. Well, absolute value is always going to be positive. That represents a distance. That number is from 0 on the number line. So the absolute value of 46 would just simply be 46. Alright, number 14. Add using a number line, which would be 6 plus negative 3. Pretty much with a number line, you'll just go 6 places to the right of 0, but for the negative 3, you'll go to the left 3 places, and you'll end up at 3. Okay? Or think of this. We're adding two numbers with different signs. You're going to subtract and take the sign of the larger absolute value. So 6 plus a negative 3 would be 3. Alright, number 15. Subtract by changing subtraction to addition. And in this case, you got negative 2 minus negative 8. So here we bring over that negative 2. When we subtract the negative 8, we change subtraction to addition and change negative 8 to the opposite, which is positive 8. When you subtract integers, you're always adding the opposite. So you have negative 2 plus 8, which will end up being 6. Okay? Alright, number 16. Write an addition fact that corresponds to the following sentence and then answer the question. On 3 consecutive passes, a football team gains 6 yards, loses 38 yards, and gains 11 yards. What number represents the total net yardage? So, to write a addition fact, the football team gains 6 yards, that's going to be a positive 6, and then we're going to add to it a loss of 38 yards, that's negative 38, plus a gain of 11 yards. In reality, you don't need the parentheses around the 11, so I can eliminate that. So you got 6 plus negative 38 plus 11. Now 6 plus a negative 38, that will give you negative 32. Negative 32 plus 11 will be a negative 21. So the number that represents the total net yardage would be negative 21. Alright, number 17. Is simplify the expression negative 6 minus, and in parentheses 6 minus 4x. Now I'm going to bring over that negative 6. Now this minus sign is going to change everything in the parentheses to the opposite. So the minus sign will make the 6 minus 6, and the minus sign makes the minus 4x a plus 4x. And then we just combine like terms here. Negative 6 minus 6, that's negative 12, and then bring down the plus 4x because we can't combine anything else with that. So the final answer there will be negative 12 minus plus 4x. Okay. Alright, number 18. Is this. Given the function f described by f of x equal to negative x minus 3, find f of negative 2. Okay. So in this case, we've got f of x is equal to negative x minus 3. And we want f of negative 2. Here we simply replace that x with negative 2. So f of negative 2 would be this. Here we got the negative sign. We bring that down. Replace that x with a negative 2 minus 3. And this is like the opposite of negative 2. That's 2 minus 3 equaling negative 1. So f of a negative 2 is equal to negative 1. Alright, number 19. Solve the equation and check the solution. Here you got negative 7 plus x is equal to 17. Okay. So here I need to get x by itself. I got a negative 7 in front, so the opposite of negative 7 would be a plus 7. So it'd be better to add 7 on both sides of this equation. You'll get x is equal to 17 plus 7. That would be 24. Number 20. Divide if possible and check your answer. Here we got negative 60 divided by 5. Well, if we do a negative divided by a positive, that's going to be negative, and then 60 divided by 5 will give you 12. So negative 60 divided by 5 will give you negative 12. And we can check by doing negative 12 multiplied by the 5, you should end up with negative 60. That's how you can check your answer. Because the opposite of division would be multiplication. Number 21. Simplify, which is negative 570 divided by 57, and then divided by negative 5. Alright, in this case here, let's see, negative 570 divided by 57, and that's going to be divided by negative 5. Well, negative divided by positive will be negative. We'll start with that. So negative 570 divided by 57 will give you negative 10. And then negative 10 divided by negative 5 will give you 2. So that will be the final answer there for number 21. Number 22 is to multiply and combine like terms where possible. So here we got negative 5 times the product, well, 5 times in parentheses a minus b. So we got negative 5 times in parentheses a minus b. So here, negative 5 times a is a negative 5a. And then that negative will make that minus a plus. 5 times b, 5b. So this will end up being negative 5a plus 5b. Okay. Alright, number 23. Solve for x. In this case, you got 12x is equal to negative 96. Now, this is a multiplication equation, so we need to do the opposite of multiplying by 12 to get x by itself, and that's to divide both sides by 12. So here x is equal to negative 96 divided by 12. That's negative 8. Alright, number 24. Write a fraction to represent the shaded region in the figure. Now in this case here, we got 7 boxes here. 4 of these boxes are shaded. So to represent the shaded region in the form of a fraction, 4 are shaded, that's your numerator, out of 7 boxes that are in that figure. So it's 4 out of 7, or 4/7. Alright, number 25. Write the fraction 48 over 56 in lowest terms. Now, there are many ways that you can reduce 48 over 56. Quick way is to find a number that can go into 48 and 56. I find the largest number that can go into 48 and 56. In this case, it would have to be 8. So I'm going to divide the numerator and the denominator by 8. So here 8 goes into 48 6 times, 8 goes into 56 7 times. So in lowest terms, 48 over 56 will be 6 over 7. Alright, number 26. Determine if the following pairs are equal by using cross products. Here we got 13 over 25 and 23 over 26. So here I need to do the cross product here of 13 and 26. So if I do 13 times 26, that's going to give me 338. And then if I do the cross product of 25 and 23, so 25 times 23 would give me 575. Now these cross products must be equal in order for these two fractions to be equal. In this case here, they're not. So here, these fractions are not equal to each other. Alright, now number 27. In 27, you're going to use less than or greater than to make a true sentence. 2/3 and 1/4. I want to know if 2/3 is either less than or greater than 1/4. Let's start with this cross product going from the upper left to the lower right, going this way. 2 times 4, that's going to be 8. And then I'm going to do the cross product going in this direction here from the lower left to the upper right. 3 times 1, that would be 3. And compare 8 with 3. In this case, 8 is greater than 3. So 2/3 is greater than 1/4. Okay. Number 28. 23 over 45 minus 4/9. Here we're subtracting two fractions here. 23 over 45 minus 4/9. I need a least common denominator for 45 and 9. In this case, it's going to be 45. Now I need to write my equivalent fractions for these two fractions here. For 23 over 45 with a common denominator of 45. Well, 45 goes into 45 one time, so 1 times 23 is 23. Now for the 4/9 with a common denominator of 45, 9 goes into 45 5 times. 5 times a 4 is 20. And now I can subtract 23 45ths minus 20 45ths. Subtract your numerators. 23 minus 20 will be 3. And we keep the same denominator. So it'll be 3 over 45. And then we can reduce in simplest form. Well, the largest number that can go into 3 and 45 would be 3. So here 3 goes into itself one time. 3 goes into 45 15 times. So in simplest form, our final answer will be 1/15 for 23 45ths minus 4/9. Alright, number 29. Change 17 over 3 to a mixed number. Change 17 over 3 to a mixed number. That's where we divide the denominator into the numerator. We divide 3 into 17. We find out how many times 3 goes into 17. That's going to go 5 times. And then 5 times that 3 will be 15. Subtract 15 from 17, you're going to get 2. And that will be your remainder. So, as a mixed number, this 5 is the whole number. The remainder is going to be the numerator. Your 3 will be your denominator. So 17 thirds will be 5 and 2 thirds. That's the final answer. Alright, number 30. You're given a mixed number of 1 and 1/3. We want to change that to an improper fraction. One and 1/3, the way we change that to an improper fraction is this. We take our denominator, multiply it by the whole number, and then add the numerator. So if I do 3 times the 1, that's going to be 3. 3 plus that 1 will give me 4. And I bring over that denominator of 3. So 1 and 1/3 as a improper fraction would be 4 thirds. Alright, number 31 is one of those word problems. A clerk sold 3 pieces of one type of ribbon to different customers. One piece was 4 5/8 yards long, another was 9 2/3 yards long, and the third was 12 3/4 yards long. What was the total length of that type of ribbon sold? The total length we're looking for, so we know we need to add those fractions together. So here we got 4 5/8, 9 2/3 yards, plus 12 3/4. Okay, we need a least common denominator for 8, 3, and 4. And by looking at this, it's going to be 24. Because I know 8 times 3, that's going to give me 24. And 24 is also a multiple of 4. So we use 24 as the least common multiple, or the least common denominator in this case. Alright, let's write equivalent fractions for this one. Starting with this one. 8 goes into 24 3 times. 3 times the 5 that's on top, that's 15. And here, 3 goes into 24 8 times. 8 times the 2, that's 16. And this next one, 4 goes into 24 6 times. 6 times 3, 18. Now we add our numerators and keep the same denominators here. 15 plus 6, that's going to be 31. 31 plus 8 will be 18 will be 49 over 24. And then add the whole numbers. 14 plus 9 is 13. 13 plus 2 is 25. So we got 25 and 49 24ths. Now that 49 over 24 is an improper fraction. So here, we need to find out how many times 24 goes into 49. That's going to go 2 times. And I'm going to have 1 left over. Now if you want to, you can do the long division like this. 24 into 49 goes 2 times. That'd be 48. Subtract that from 49, you'll have 1 left over. So it'll be 1 over 24. Now add the 2 to the 25, you'll get 27 and 1/24. So the final answer there, the total length of that type of ribbon sold would be 27 and 1/24 yards. Okay, number 32. I'll do this on another sheet. Okay, here we go. Number 32. Terry worked 14.5 hours over a 3-day period. If she worked 4.5 hours the first day and 3.25 hours the second, how many hours did Terry work on the third day? Alright, let's add up the total number of hours that she worked on the first and the second days, which was 4.5 plus 3.25. Here we need a least common denominator for 4 and 2, which is in this case going to be 4. Now for the 1/2 with a equivalent fraction or common denominator of 4, 2 goes into 4 2 times. 1 times the 2 would be 2. For 3 1/4 with a common denominator of 4, 4 goes into 4 1 time. 1 times 1 would be 1. Now if we add 2/4 and 1/4, you're going to get 3/4. Add 4 plus 3, you're going to get 7. So for the 2 days, she's worked 7 3/4 hours. Now we need to know how many hours that she worked on the third day. She worked a total of 14.5 hours. 7 3/4 hours was the total number of hours that she worked on the first and second days. Alright, so let's subtract 7 3/4 from 14.5. I like to change these to an improper fraction here. So if I do 2 times 14, that's going to be 28, plus that 1 would be 29 over 2. 4 times 7, that would give me 28, plus 3 would be 31 over 4. Now let's find the least common denominator for 2 and 4. Again, that's going to be 4. Now for the 29 over 2 with a common denominator of 4, 2 goes into 4 2 times. 2 times 29. That'd be 58. And then 4 goes into itself 1 time. 1 times 31 will be 31. Subtract 58 minus 31, you're going to get 27 over 4. And then I can write that as a mixed number. How many times 4 goes into 27? That's going to go, I think, 6 times, with 3 left over. So it'll be 6 3/4 hours. And to prove that, let's go 6 times. Subtract 24 from 27, you get 3. So it'll be 6 3/4 hours that Terry worked on the third day. Alright, number 33. Here you're going to multiply 2 15ths times 3/8, and you're going to write your answer in simplest form. Sometimes you can do cross cancellation with some of these multiplication problems that have fractions in them. Like in this case here, I know 2 and 8 has a multiple of 2. They're multiples of 2. So if I divide 2 into itself, that's going to go 1 time, and 2 goes into 8 4 times. 3 and 15 are multiples of 3. Divide 3 into itself, that goes 1 time. Divide 3 into 15, that's going to go 5 times. So in this case here, if I multiply the 1 times the 1, I'll get 1 over 5 times 4. 20. So it'll be 1 over 20. Okay, number 34. What is the multiplicative inverse of 4 and 5 6? In other words, what would be the reciprocal of 4 and 5 6? The first thing you need to do here is change that to a improper fraction. So if I do 6 times 4, that's going to be 24. 24 plus 5 would give me 29 over 6. So 29 over 6 will be the improper fraction. Now for the multiplicative inverse or the reciprocal, we just flip this over. The numerator becomes your denominator becomes your numerator. So the multiplicative inverse is 6 over 29. All I did was invert this improper fraction to get its reciprocal or multiplicative inverse. Number 35. Solve by using the multiplication principle. 2/3 z is equal to negative 1 over 5. Alright, normally you would divide both sides by 2/3. Here we're dealing with fractions here, so it would be much easier to multiply both sides by the reciprocal of 2/3 in order to get z by itself. The reciprocal of 2/3 would be 3 over 2. Now I'm going to do the same thing here. Multiply that negative 1 over 5 by its reciprocal, 3 over 2. So here I'm going to get z by itself. And then that's equal to, I'll do negative 1 times 3. That's negative 3 over 5 times 2, which is 10. So here negative 3/10 will be what z is going to be equal to. Okay. Number 36. Multiply and simplify. 2 to the 5th times 2 to the 4th. Here we're multiplying powers of the same base, so here we just simply add the exponents. So here we bring over the base of 2 and add 5 plus 4. And 5 plus 4 is 9. So 2 to the 5th times 2 to the 4th will equal 2 to the 9th. Okay. Number 37. A sporting goods manufacturer requires 5-6 yards of fabric to make a pair of soccer shorts. How many shorts can be made from 20 yards of fabric? So 20 yards of fabric will be divided by the 5-6 yards to find out how many shorts can be made. So here's our problem. 20 divided by 5-6. So here, that 20 is a whole number. I'm going to put that over 1, so it'll be 20 over 1. Now, when we divide fractions, we always multiply by the reciprocal of this. So the reciprocal of 5 over 6 will be 6 over 5. Now here I can do some cross-dividing here. 20 and 5 are multiples of 5, so if I divide 5 into itself, it goes 1 time, and 5 into 20, that's going to go 4 times. So here 4 times 6 will be 24. So to answer that problem's question, 24 shorts can be made from 20 yards of fabric. Number 38. There are 56 males and 36 females in a school marching band. Find the following ratios. Part A is female band members to total band members. Let's start with that. Female to the total. There are 56 males and 36 females, so if I add 56 and 36, that's going to give me 92. There are 36 females, so that means that's going to be 36 to Here we use the colon for the ratio. The total, which is 92. Now, subtraction, that's going to be 36 over 92. Now, I'd like to reduce that in simplest form. So here we're going to divide both sides, the numerator and the denominator by, I think by 4. This will give me 9, and then 92 divided by 4 will give me 23. So that ratio is going to be 9 over 23. So that's part A. In part B, they ask for female band members to male band members. Female band members to male band members. So now it's female to male. We got 36 females to 56 males. So subtraction, that's going to be 36 over 56. And I think 4 is the largest number that can go into 36 and 56. So we divide the numerator and the denominator by 4. That will be 9 over 14. So the ratio of female to male band members will be 9 over 14. So that's question 38. Number 39. Solve for x. So here, this is just a proportion here. X over 25 is equal to 10 over 50. So here we need to do cross multiplication for this particular problem here. So if I do x times the 50, that's going to give me 50x equal 25 times 10. That will give me 250. So I got 50x is equal to 250. And then divide both sides by 50. X will be equal to 5. Okay, so that's how we solve a proportion. In number 40, we have to set up a proportion. There are approximately 4 pounds of muscle for every 5 pounds of body weight of a certain animal. For a 130-pound animal, how much of the weight is muscle? So 4 pounds of muscle for every 5 pounds of body weight. That ratio will be 4 to 5. Here, it's going to be muscle to body weight. Our other proportion has to be muscle to body weight. We have to be consistent with our ratios here. If this is going to be muscle to body weight, the other ratio must be muscle to body weight. Now, we're given a 130-pound animal. That's the body weight of the animal. We're looking for the weight that is muscle. So here, I'm going to let X be the muscle weight of a 130-pound animal. Okay? Muscle to body weight. Muscle is what we're looking for to the body weight of 130 pounds of that animal. Now we have our proportion that we can solve for X. Cross multiply 5 times X, that's going to be 5X equal 4 times 130. That's going to give me, I think, 520. Yeah. And then to solve for X, we're going to divide both sides by 5. So that means that X is equal to 104. So to answer the question, for that 130-pound animal, 104 pounds of it is muscle. Number 41. Find the best buy based on price per unit for cereal. Part A, well, a 13-ounce size for $3.59, 28-ounce size for $5.69, 34-ounce size for $6.19. Here we take the price, divide that by the number of ounces. That would give us the price per ounce. So here, we got $3.59 for a 13-ounce box of cereal. So we divide $3.59 by 13. And we're going to round to 2 decimal places because we're dealing with money amounts here. In this case, it's going to be 28 cents approximately. And the B option is 28 ounces for $5.69. So we take $5.69, divide that by 28. And this will give us 0.20 or 20 cents per ounce. And then part C, well, the C option, a 34-ounce size for $6.19. So $6.19 divided by 34. 6.19 divided by 34. That's going to give us, to 2 decimal places, 0.18. Now, the smallest price per unit would be the better buy. In this case, if you look at these options here, it's going to be option C, where you have a 34-ounce size for $6.19. So 34 ounces, or a 34-ounce size for $6.19. That would be the better buy than the other two. Okay. All right. And finally, number 42 is this. On a map, 1 inch equals 10 miles. If 2 cities are 3 inches apart on the map, how far are they actually apart? We can set that up as a proportion here. In this case, 1 inch equals 10 miles, so that's going to be 1 over 10, inch to miles. So our other proportion has to be inch to miles. We're told 3 inches apart, so the 3 goes in the numerator. And we're finding out how far are they actually apart. That's going to be our x. Okay? We have to be consistent here. Inches to miles, inches to miles. And then we just do our cross products and then solve for x. Well, 1 times x, that's going to be 1x, so just x, and that's equal to 10 times 3, which will give you 30. And pretty much we got this solved for x here, so actually it'll be 30 miles that the 2 cities are actually apart. Okay. Alright, so this should be enough to assist you with exam number 2, which will be on the 23rd, which is on a Monday. Feel free to email me or come by my office if you have any questions about any of the problems that I've gone over on this particular video. And do watch this video as much as you need to. Good luck.